Hello everyone, this is Darshani from Sri Venkateswara College of Engineering, studying in the Department of Computer Science and Engineering. Today's subject is Introduction to Mechanical Engineering. Automobile industry. What roles does automobile industry play in our daily life? How do they work? What are IC engines? Classification of IC engines, working principle of IC engines, components of IC engines, advancements. Next step. What role does automobile play in your daily? An automotive industry comprises a wide range of companies and organizations involved in the design, development, manufacturing, marketing, selling, repairing, and modifications of motor vehicles. It is one of the world's largest industries by revenue. How do they work? What is IC engines? An internal combustion engine, ICE or IC engine, is a heat engine in which the combustion of fuel occurs, which an oxidizer in a combustion chamber that is an integral part of working fluid flow circuit in an internal combustion engine. The expansion of high temperature and high pressure gases produced by combustion applies direct force to some component of the engine. The force is typically applied to pistons, turbine blades, a rotor, or a nozzle. This forces moves the component over a distance, transforming chemical energy into kinetical energy, which is used to propel, move, or power whatever the engine is attached to. Types of IC engine: 4 stroke, diesel and petrol, 2 stroke. Working of four-stroke engine, petrol. Intake stroke. In a four-stroke cycle, petrol engine during suction stroke, the air fuel mixture is introduced to combustion chamber, whereas in four-stroke cycle, diesel engine during the suction time, only pure air is drawn by piston. The piston moves from TDC, top dead center, to BDC, bottom dead center. TDC is the furthest position of the piston and BDC is the nearest position of the piston to the crankshaft. As the piston moves towards the BDC, it creates a low pressure area in the cylinder. The intake valve remains open to few degrees of crankshaft rotating after BDC, and as the intake valve closes, it seals the air fuel mixture in the cylinder during suction. The inlet valve remains open, the outlet valve remains closed, and crankshaft rotates to 180 degrees. Compression stroke. The air-fuel mixture trapped during suction is compressed inside the cylinder during the compression stroke. The piston moves from BDC to TDC to compress the air-fuel mixtures. The piston moves forward with the help of flywheel momentum on compressing the air-fuel mixture. More energy is released on charge ignition. The energy is the volume of compact air-fuel mixture sealed in the combustion chamber, ready for ignition during compression. Both inlet and outlet valves remain closed and crankshaft rotates to 180 degrees more. Now the total rotation of the crankshaft is 360 degree. Combustion stroke. It is also called a power stroke. After the compression, the crankshaft completes one full rotation and its second rotation begins. When the compressed air fuel mixture is kindled with the help of a spark plug, the power stroke occurs. Combustion is rapid process and oxidizes chemical reactions, releases heat energy. The hot expanding gases force the piston away from the head of the cylinder during combustion. Both inlet and outlet valves remain closed and the crankshaft rotates to 180 degrees more. Now the total rotation of the crankshaft is 540 degrees during the power stroke. As the piston reaches the BDC, the cylinder is filled with exhaust gases and the combustion is completed. Exhaust stroke. During the exhaust stroke, the exhaust valve opens and the inertia of the flywheel and other moving parts pushes the piston back to the TDC and allows the exhaust gases through. The open valve. The position of piston is at TDC, so at the end of the exhaust stroke, one operating cycle of the engine has been completed. During exhaust stroke, the inlet valve remains closed, the outlet valve remains open, and crankshaft rotates to 180 degrees. Now the rotation of crankshaft is 720 degrees. Four-stroke engine, diesel. Intake stroke. Intake stroke occurs when the air fuel mixture is introduced to the combustion chamber. In this stroke, the piston moves from TDC to BDC. The movement of piston towards BDC creates a low pressure area in the cylinder. The inlet valves remain to open a few degrees of crankshaft rotation after BDC. The intake valve then closes and the air fuel mixture is sealed in the cylinder. Compression stroke. In compression stroke, the trapped air fuel mixture is compressed inside the cylinder during the stroke. The piston moves from BDC to TDC, compressing the air fuel mixture. Then the momentum of the flywheel helps the piston move forward. Compressing the air fuel mixture allows more energy to be released when charge is ignited. The charge is volume of compressed air fuel mixture trapped inside the combustion chamber ready for ignition. The inlet and outlet valve must be closed to ensure that the cylinder is sealed, resulting in compression. Combustion stroke. The second rotation of crankshaft begins when it completes a full rotation during the compression stroke. The power stroke occurs when the compressed air fuel mixture is ignited with the help of spark plug. Ignition or combustion is the rapid oxidizing chemical reaction in which a fuel chemically combines with oxygen in the atmosphere and releases energy in the form of heat. The hot expanding gases force the piston head away from the cylinder head. Exhaust stroke. As the piston reaches BDC during the power stroke, combustion is completed and the cylinder is filled with exhaust gases. The exhaust valve opens during the stroke and the inertia of the flywheel and where moving parts push the piston back to TDC, forcing the exhaust gases through the open exhaust valve. At the end of exhaust stroke, the piston is at TDC and one operating cycle has been completed. Diagram for four-stroke engine. First figure shows the intake, second shows compression, third shows expansion, and fourth shows exhaust. Two-stroke engine cycle. Downstroke. The piston moves from TDC to BDC, letting the fresh air entering the combustion chamber. The fresh air fuel mixture gets into combustion chamber through the crankcase in this stroke and crankshaft makes the rotation of 180 degrees Celsius. Upstroke. The piston is pushed from BDC to TDC. As a result, the fuel air mixture gets compressed and the spark plug ignites the mixture. The mixture expands and the piston is pushed down. The inlet pot is opened during the upstroke. While the inlet pot is open, the mixture gets sucked inside the crankcase. When the mixture is pushed up into combustion chamber during the previous upstroke, a particle vacuum is created as no mixture is left behind in the crankshaft. This mixture is ready to go into the combustion chamber during the downstroke but remains in the crankcase until the piston goes up to the TDC. In this stroke, the crankshaft moves rotation of 180 degrees Celsius. Application of two-stroke engines. Two-stroke engines are preferred when mechanical simplicity, lightweight, and high power to weight ratio are designed priorly. They are lubricated by traditional method of mixing oil into the fuel. They can be worked within any orientation as they do not have a reservoir dependent on gravity. This makes desirable for their use in handle tools such as chainsaws. Two-stroke engines are found in small scale population applications such as motorcycles, mopeds, and dirt bikes. Compat- Competitive comparison of two and four strokes. Two-stroke. It has one revolution of crankshaft during one power stroke. It has four-stroke. It has two revolution of crankshaft during one power stroke. It generates high torque. it generates less torque. It uses part of the fuel's outlet and inlet. It uses valves of the fuel outlets and inlets. It has a larger ratio in terms of power to weight. Its engine result in higher thermal efficiency. Requires more lubricating oil as some oil burns with fuel. It has lesser ratio in terms of power to weight. It generates less smoke and show more efficiency. Difference between petrol and diesel engine. Petrol engine draws a mixture of petrol and air during suction stroke. Diesel engine draws only air during suction stroke. Petrol engine. The carburetor is employed to mix air and petrol in required proportion and to supply it to the engine during suction stroke. Diesel engine. The injector is employed to inject the fuel as the end of the compression stroke. Petrol engine. The compression ratio ranges from 7 is to 1 to 12 is to 1. Diesel engine. The compression ratio ranges from 18 is to 1 to 20 is to 1. Petrol engine. The charges is the ignited with the help of spark plug. This type of ignition is called spark ignition. Diesel engine. The accomplished by compressed air which will have been heated due to high compression ratio to the temperature higher than the ignition temperature of the diesel. Thank you.